Hello everyone, welcome to Programming Knowledge. I am going to start a lecture series on Python socket programming. Well, some of you might be wondering about what are you going to learn here. Well, if you learned programming, you must have wondered, okay, we know programming, but what to do with it? What's its practical implementation? Af- After all, no one is going to give you an stack or queues and will ask you to pop it, post it, right? Real world problems that are solved by programming are different and complicated. Well, in this lecture series, you will come across some awesome practical implementation of Python socket programming. Let's discuss course outline. We start with the basic of networking, which include core networking concept like IP addresses, TCP, UDP, HTTP protocols, email protocols like SMTP, file transfer protocol FTP, and internet protocol. The best part of this lecture series is that here we only not cover the basics theory, but we also see how to work with these protocols in Python. One point here is to note that we are considering the viewer have some understanding of computer networks and all of these protocols. Here in this lecture series, we will not cover the in-depth theory of computer networking, but we cover some key concept of networking such that you are all able to follow the tutorial easily. After the understanding of basic of networking, we will see the socket programming. In this topic, we will see basics of socket and then we will cover working with TCP and UDP socket for writing low-level applications. Thereafter, we will look at writing client and server program for socket-based communication. Now, here is the requirement for the lecture series. In this lecture series, I am using Windows operating system, but all these are also applicable for Linux or Ubuntu. In this lecture series, I am using Python 3 for the coding or implementation purposes. And of course, all the implementation or coding part of the video require internet connections. So make sure all these are satisfied before starting this lecture series. Okay. Okay. Let's get started with something you are likely to be familiar with. That is IP addresses. They are typically look like this. They are actually a single 32-bit number, but though they are usually written just like the number shown here. They are written in the form of four decimal number that are separated by dots. The number are sometimes called octet or bytes because each one represent 8 bit of the 32-bit number. Such each octet can only take value from 0 to 225. Okay. So valid IP address ranges from 0.0.0.0 to 255, 255, 255, 255. This way of writing IP address is called dot decimal notation. Okay. Basically, IP address perform two main functions. IP address uniquely address each devices that is connected to a network, and it helps the traffic to be routed between the network. You may have noticed that the network connected devices that you use have IP address assigned to them. The important point to note here is that each IP address that is assigned to a network device is unique, and no two devices can share an IP address. Okay. You can find out what IP address have been assigned to your computer by writing just ipconfig/all on window. If you want same on Linux system, then just type ipaddr. Okay. IP address can be assigned to a device by a network administrator in one of two ways. Statistically, where the device operating system is manually configured with the IP address, or dynamically, where the device operating system is configured by using the DSCP protocol, that is, Dynamic Host Configuration Protocol. When using DSCP, as soon as the device first connects to a network, it is automatically allocate an address by a DSCP server from a predefined pool. Some network devices such as home broadband router provide a DSCP server service. Otherwise, a DSCP server must be set up by a network administrator. DSCP is widely deployed and it is particularly useful for network where different devices may frequently connect and disconnect. Such networks are like public Wi-Fi hotspot, mobile networks, etc. Basically, the internet is a huge the internet is a huge IP network, and every device that sends data over it is assigned an IP address. The IP address space is managed by an organization called IANA, that is Internet Assigned Number Authority. IANA decide the global allocation of IP address ranges and assign block of address to RIRs, Regional Internet Registries, who then allocate address block to countries and organizations. There are some special IP address ranges IANA has defined. That ranges is called private addresses. This range will never be assigned to any organization, and as such these are available for anyone to use for their network. The private ranges are here as follows: 10.0.02, 10.255, 255, 255, 172.16 to 00 to 172.31.255.255, and 192.168.0.02, 192.168.255.255. You may be thinking that if anybody can use them, then wouldn't that mean that device on the internet will end up using the same address, thereby breaking the IP's unique address property? Yeah, if you are thinking like that, then that is a good question. And this problem has been avoided by forwarding traffic from private addresses from routed over the public network. Okay. Wherever a wherever a network using private addresses needs to communicate with public internet, a technique called network address translation is used, which essentially makes the traffic from the private network appear to be coming from a single valid public internet addresses. And this effectively hide the private addresses from the internet.
Now, we will start with the socket series. In this socket series, we will cover the background of socket programming, socket API overview, and after that, we will start working with TCP and UDP sockets. As we know, Python provides a good coverage on the low-level networking interface. So you can assume that Python has a socket module that gives you the necessary functionality to work with socket interface. If you have ever done socket programming in any other language like C, C++, Java, then of course you will love the Python socket module because it is very easy. In this lecture series, we will explore the socket module by creating a diverse range of Python scripts. Okay. So network programming in any programming language begins with socket, as we all know. So the question comes in mind, what is socket? So if we define in a simple word, not in a very technical way. So in simple word, a network socket is a virtual endpoint where entities can perform inter-process communication. Let's take an example to understand it clearly. For example, one process sitting in a computer, okay, exchange data with another process sitting on the same or another computer. We typically label the first process. We have already covered the process and the ports, how it communicate in the previous lecture when I am discussing TCP and UDP. So we typically label the first process which initiate the communication as the client. It is very important point. Which initiate the communication is referred to as a client and later one as a server. Okay. So Python has a quite an easy way to start with socket interface. In order to understand this better, let's see the big picture first. Let's see a following diagram. In this diagram, a flow of client-server interaction is shown. Let's understand it very deeply. This will give you an idea of how to use Socket API. So, in the interaction between typical client and a server, the server processes has to work a bit more. Means there is a confusion that only client have to work more, but the reality is the server has to work more than a client. We will see how. So let's see here. After creating a socket object, first let's see server part. So when we create a socket object, the server process binds that socket to a particular IP address and port. So this is much like a telephone connection with an extension number. So in a corporate office, after a new employee has been allocated with his desk phone, usually he or she will be assigned to a new extension number. So if anybody makes a phone call to this employee, the connection can be established using his phone number and extension number. Okay. Same thing is like IP address and port. So after the successful binding, the server process will start listening for a new client connection. Okay. Now, for a valid client session, the process can accept the request of the client process. At this point, we can say that the connection between client and the server has been established. Okay, this is a very important point when the connection between client and the server will be established. Okay, then the client or server enters into request response loop. The client process sends data to the server process and the server processes the data and return a response to the client. When the client processes finishes, it exits by closing down the connection. Okay. At that moment, the server process probably goes back to the listening state. Okay. The above interaction between client and server is very simplified representation of actual reality. It is only for understanding purpose. In practice, any production server processes process any production server process has multiple thread or sub process to handle concurrent connection from thousands of clients over respective virtual channels. So it is very simple simplified diagram to start with. Okay. So in this lecture we have covered some beautiful point about what is socket, how we visualize the socket, and we have also seen a diagram which is helps you to clarify the socket API overview, which you clarify the socket, how socket API works. But as I have said earlier that this diagram is very simplified version of the actual client server interaction. This is for the understanding purpose.
Till now, we have completed the basic of sockets, and we have also seen that what is socket, and we have seen simple interaction diagram uh, between client and server using socket. That is, we have seen a socket API, how socket API works. Now, today we are going to start working with TCP socket. So creating a socket object in Python is very straightforward. I think you all know that. You just need to import the socket module and call the socket class. So open up your ID. I am using PyCharm here, or even you may use another ID which you love to use. So if you want to import all the things from the socket module, then just write from socket import star, or you can simply import socket. Okay. Now let's create TCP socket. For creating TCP socket,
you have to write as is equal to socket dot socket, and here the class, this class takes plenty of parameter. Okay, so the important one I am using here. If you want, you can refer to the documentation of socket. So some important parameters are, first one is socket family. The socket family is the domain of socket. The example of domain of socket is like uh, AF inet. Approximately 90% of the socket of the internet fall under this category. Okay, and there is also one family is AF Unix, which is sometimes used as well. In Python 3, you can also create a Bluetooth socket. Yeah, this is very interesting point. You have to just write AF underscore Bluetooth. Now, the second parameter is socket type. Depending on your need, you have to provide the socket type. Socket type is what you want to work for. If you want to work for TCP socket, then you have to provide sock underscore stream. And if you want to work with UDP socket, then you have to provide here type is equal to sock underscore dgram. Okay. Now there is third parameter, but it is also not very important. But this specifies the variation of protocol within a socket family and type. Okay. Usually we left it as 0. Okay. Now for many reason means there are various reason which leads to socket operation unsuccessful. For example, if we take an example, if you don't have permission to access a particular port as a normal user, then you are not able to bind to a socket, right? So this is why it is a good idea to do proper error handling when creating a socket or doing some network bound communication. Okay, so let's try to connect a client socket to a server process with proper error handling. Again, I am repeating, here I am using TCP client socket. So here type is socket underscore stream. Okay, so let's start. As I said, just import socket, and I am also importing one module which is sys module, which is system module in Python. Now let's start with try. In try, we have to write a reference variable. I am taking as sock is equal to socket dot socket, and in that we have already discussed the parameters. Here I am using socket dot af underscore inet. If you want to use Unix, then it is up to you. And I am making a TCP client socket. That's why I am providing socket dot sock underscore stream. Now, if socket is not able to create it, then what we will do? Then we will use except block. In except block, just write socket dot error as err, and here just I am printing socket is failed to create, and the reason is ERR. The reason is stored is in ERR. So we are printing also that if except block will not executed, then the socket is created, right? So also I am printing that let's say socket created. Now I have to reach to the server process. So I have to provide target host and target port number, as I have already discussed that telephone number and extension both are required. So here target host, let's take a input by a user. So target underscore host is equal to input of let's say enter the target host name to connect. Target port is equal to input of enter the target port number. Okay. Now again I am defining in a try block and except block. It is a very good programming practice. So try to do like this only. It will make your program very effective. So in try block, just try to connect to the target host, and since target host is in a string, so I am providing directly like that, and target port have to be integer, so I have to convert it into integer. So in Python you have typecasting is just like int, and in that I have to provide the string, right? And after that let's print that socket connected, and also print target host in which it is connected, and also the port number. Let's print it out. Okay. Now after connection, let's close it also. Sock dot shutdown. Okay. Here I am providing two. Now if it is not gets connected, then print fail to connect, and also provide target host and target port that this is the target which we are not able to connect, right? And also we are able to um, print the reason. So in except just define socket dot error as ERR and printed it, because after printing ERR it will show you why what error has happened. So let's run this code. Yeah, and now enter the target host name. So I am connecting to www.python.org, let's suppose, and the obviously target port is 80. It is standard. So yeah, it is showing socket connected to www.python.org on port number 80. But however, if socket creation has failed for some reason, such as invalid, if you provide invalid DNS, and output similar to the so output is very similar, but socket will be created, but it is not able to connect, right? So let's if you provide invalid DNS, if you provide invalid host, the suppose www.abc.invalid, and the port number let's say 80. So here you see that it is failed to connect on port number this, and the reason here is important. Name or service are not known. So I think that you are able to understand how to use socket interface of Python to connect to a client to connect to a server process using a TCP client socket. In the previous lecture, we have seen that how to use socket module, and also we have written the TCP client program to connect to the server process. Now, in this lecture, we are going to see the TCP client server interaction using socket module of Python. In the previous lecture, we have seen the client server interaction diagram in detail. And in that diagram, we have understood that the server process needs to carry out a bit of extra work, right? So what extra work? So it needs to bind to socket address and also listen for incoming connections. Now, let's write code to understand it clearly. Let's start with writing TCP server program which sends the data to the client and also receive data from the client. So open your IDE. I am using PyCharm here. So we are going to write TCP server program here. So let's start. As you all know now that we have to first import the socket module. So import socket. Now let's create a socket object. So let's server underscore socket is equal to socket dot socket, and here we have to pass the required parameters. As we have seen in the previous video also, the first parameter is af underscore inet and second one is sock underscore stream. As we have seen also that af underscore inet referred to address family of IPv4 and sock underscore stream means connection oriented TCP protocol, right? Now let's see interaction diagram to visualize it clearly. As you see here that server first bind the socket to a specific IP and port so that it can listen to incoming request on that IP and port. So to do this thing, server has a bind method which bind it to a specific IP and port, and server has a listen method which puts the server into the listen mode. So first let's bind it. So server underscore socket dot bind. Here we have to pass the server address. So server address, as we have seen, that server address is IP address as well as port number. So I am using local host here. That's why I am passing 127.0.0.1 and port number. As we have seen in the previous videos that port should be an integer and ranging from 1 to 65535, right? And also 0 is reserved. So let's suppose I am using port number 12345 which is in the range of this range. Okay. Now let's listen now. Server started to listening after binding. So server underscore socket dot listen. Here Listen takes a backlog parameter. So suppose I am passing 5. So 5 here means that the 5 connection are keep waiting if the server is busy. And if a sixth socket try to connect, then the connection is refused. Okay. Now, at last, we make a while loop and start to accept all incoming connection. So I am writing a while infinite loop. So while true, here I am printing a server waiting for connection. Now, as we have seen in the interaction diagram, now we have to accept. So in Python socket module, there is an accept method. The accept method initiate a connection with the client, as we have seen. So uh, here the accept method basically return two things. It return a new socket object representing the connection and tuple holding the address of the client. So let's client underscore socket comma address is equal to server underscore socket dot accept. So here the object will be go into the client underscore socket and the address will go under ADDR address, right? So let's print this address. So let's print client connected from ADDR. Let's write another infinite while loop to get the data and send the data to the client. So while true, let's receive the data by the client using recv method of the Python socket module. This method receive at most 1024 bytes. So data is equal to client underscore socket dot recv receive and 1024. It takes at most 1024. Now, if data is not received or if data is end, then we have to break. So if all the data is received, then we have to break this while loop. So let's break it. And also we are printing that data. So, and also we have to, you all know that we have to decode this into UTF-8 string, right? So print receive from client data dot decode, and we have to convert decode into UTF-8. Now let's send data to the client also. So here I am putting this send method into the try and accept block. So if it is not able to send, then it will or if we do a keyword interrupt, then it will exited. So try client socket dot send. Uh, Here uh, the string will not be sent. Here the type of the here the type is bytes, not a string. So we have to convert the string into byte in UTF-8. So bytes. Suppose I am sending the message hey client. So hey client, and we have to convert into decode into UTF-8. So let's do that or accept If keyboard interrupt, then print exited by the user. Okay. Now, at the end, we have to close the connection between server and client. So let's client underscore socket dot close and server underscore socket dot close. Okay. So let's run this code. Now, as you see here, it is showing server is waiting for the connection. In this video, we have seen that how to write TCP server program which sends the data to the client as well as receive the data from the client. So in the previous video, we have seen the TCP server program. And now in this lecture, let's write TCP client program such that we are able to see the interaction between client and server. We are going to write the program according to the interaction diagram which we have seen previously. By doing this, it will give you a clear picture in terms of theoretical as well as practical knowledge. So let's look at a diagram again. I have also followed this diagram to write the server program as well. So, as you see here, first we will create socket object and then we will connect to the server using IP address and port number. And then we will send and receive the data between client and server. So, let's begin. Open your IDE to start coding. I am using PyCharm to do coding. So, as we now all know that we have to import the socket module. So let's import socket. And then we make a socket object as we have seen previously, like I am defining reference variable as client underscore socket is equal to, and let's create an object socket dot socket, and in same here I am passing the argument like socket dot af underscore inet, which is belongs to IPv4 family, and socket dot sock underscore stream, which is a TCP, which signifies the TCP protocol, right? Now we have to connect to the local host on port number 12345. So this port number, as we have seen in the previous lecture, we have taken the port number as 12345 in the server program, right? So here we have to provide the same port number on which the server program is running. Okay, so client underscore socket dot connect, as we know already that now it takes a tuple of port IP address as well as port number. So here I am connecting to the local host, that's why I am passing IP address as 127.0.0.1 and the port number 12345. Now let's try to send the data to the server and also receive some data from the server. So I am defining a variable named payload and I am assigning a message. Payload is just a message. So I am just assigning payload as hey server. So we are going to write the send message method and try and accept block. So let's write try, and here we have to write in an infinite loop. as we have seen in a interaction diagram, we go repeatedly in a receive and send method. So while true, now as we already know in a previous lecture that we have to use send method to send any payload or message. So basically send method in Python socket module takes argument a payload or message which is in a UTF-8 string format. So let's write client underscore socket dot send, and you have to pass a payload dot encode into UTF-8 string. So you have to pass a UTF-8. Okay. And now again let's receive the data as well from the server using receive method. We have seen also this method in the previous video. So data is equal to client sock underscore socket dot receive means recv, and we have to here remember we have to pass here the buffer size, right? So it takes at most 1024. So let's pass it and let's print the data. So print str data. So again let's play a little bit with this program. So let's take a user input also to make a more interactive. So let's take a user input to send the data to the server as well. So let's mode is equal to input of want to send more data to the server, and if users say yes, then we will take a input, and if you say no, then we will break. So if more dot lower just convert into lower, so more dot lower is equal to y or yes, then payload is equal to just take a input into the payload, so or else break. And in accept block let's take a keyword input to break to get out of it, and let's print that exited by the user. And as we have seen that in an interaction diagram we have to also close. So client underscore socket dot close, right? So let's run this program. Okay, as we have already just see we have already written the program of the server. So when you run the program of the server, so it is writing server waiting for the response, right? Now waiting for a connection. So now let's run the client program. So here as you see that it says hey client, that means that it receives the data from a server. So as you see in a server program, I am sending the data hey client to the client, and if you see the server, then you get here that received from the client uh, hey server, right, as you see here. And if you go into client part, then it is also saying want to send more data to the server. If you say yes I want to send, then it says enter payload. So suppose I am writing my name, let's suppose Mohan. So if you run it, then again it comes hey client and want to send more data, and if you see the server, then you get okay received from the client. So as you see here, the interaction between client as well as server, it is in a local machine. Both the program is running in a local machine. That's why I have uses this local IP address. But you can do this and also you are able to play with this program. So try this program and experiment with this program. We are going to work on UDP socket. Before going to the coding part, let's understand the client-server interaction diagram of UDP socket. As we have seen in the basic of networking that UDP is connectionless protocol, right? That is, the client does not form a connection with the server like in TCP and instead just it sends a datagram and the server need not accept a connection and it just waits for datagram to arrive. And datagram contains the address of sender which the server used to send the data to the correct client. We also know that UTP does not check for error in the exchanged datagram, right? So it gives that is why it gives very fast communication. Now, as you see in the interaction diagram, it is very similar to TCP, but there are various major changes. In UDP, after creating a socket object, in UDP, after creating a socket object, the server process bind that socket to a particular IP address and port number. After successful binding, the server process will start waiting until datagram packet arrive from client. In TCP, we have seen the concept of listen and accept, which makes the TCP connection-oriented protocol. But in UDP, there is no such thing. That's why it is a connectionless protocol. Now, after binding, the client server enters into the request response infinite loop. When the client process finishes, it exits by closing down the connection, and at that moment the server process probably goes back to the waiting state. I am again repeating here that this interaction diagram is a very simplified representation of the actual reality. In practice, any production server process has multiple threads or sub-processes to handle concurrent connection from thousands of clients over respective virtual channels. Now, let's jump to the coding part. I am using PyCharm IDE for coding. Let's create UDP server first. As we all now know that first we have to import the socket module. Now, let's create socket object. So sock is equal to socket.socket. Here we have to pass an argument, uh, two argument. In this, the first argument we all know is socket.af underscore inet, which belongs to IPv4 family. And the second argument we have to pass here is socket.sock underscore dgram. The sock underscore dgram here means that the connectionless UDP protocol. As we have seen in the interaction diagram, we now have to bind the socket with IP address and port number. So there is a method called bind as we have seen already. Here in bind, we have to pass one tuple, and the tuple consisting of IP address and port number. Here again, in previous lecture, I am providing localhost and port number. So localhost is nothing but 127.0.0.1 and port number, let's suppose 12345. Okay. Now let's write infinite loop for sending and receiving data. So while true, for sending the data, usually to send the data using UDP protocol, we use RECV from method of socket module. So RECV from returns two things, that is data as well as address. That is very important point here. So let's write first. So data comma address is equal to SOCK dot RECV from. Now in TCP, here why we are not using RECV method which we have used in TCP? Because in TCP, once the connection gets established, the address information does not change, right? But in other hand, in UDP, UDP is a connectionless protocol. So here we have to also receive the address so that we want to send the data back. So that's why in RECV from there are two things, data as well as address. But in RECV method we only have data part because the connection is established. Here the connection is not established. If we want to send back the data to the correct client, we want address as well, right? And in RECV from we have to pass an integer, and this integer represent the number of byte you want to accept. So here we are trying to provide enough byte to cover the entire message, because we have seen in the background of networking that the packet of UDP message should be equal to the message size of the UDP should be equal to the packet size, right? So here we are trying to provide enough bytes. So I am providing here, let's say 4096 bytes. Now let's say we have to also send the data to the client. So let's define message is hello, I am UDP server. Here also one important point is here we use send to method here for the UDP. The logic is same why we are using another method, because we have to send the data to a particular address, and in UDP there is no connection established. That's why we have to specifically provide the address. So that's why there is another method send to. So let's write sock dot send to. It's take two argument. One is message and another one is address. And also let's print the data that we have received from the client, that is received from. Let's print the data, print data. Okay. Now, and also the message should be in bytes. Here it is in a string, but we have to send the message should be in byte. So let's convert into bytes. So bytes of hello. Okay. And also we have to encode this message, right? So dot encode in UTF-8 string. Okay. Now let's write a simple client program which is able to interact with this server program. All things are similar, somewhat similar. So I am copying from the server program up to this part. Right. Now I want to send a message to the server. So let's define a message. Hello UDP server. Again, we know to send message here, we have to use send to method. So client underscore socket dot send to, and we have to encode the message as we all know into UTF-8. and we have to forward this. We have to send the message into the local host, the address. So I am providing 127.0.0.1 and the port number is 12345, right? And also if the server send, so we have to receive that. So data comma address is equal to client underscore socket dot receive from, and also here I'm providing 4096. And let's say print server says, and again print the data. So print str data, and after that we have to close the connection. Now let's run the code. So first we will run the code of the server, and now let's run the code of the client. As you see here, it says hello, I am a UDP server. And now if we go to the server output, we will see it prints hello UDP server. So in this lecture we have seen the message successfully receive and send between the server and the client, and we also able to get knowledge about how UDP socket works. Till now we have completed up to working with UDP socket. Today we will going to see handling multiple connection between client and server. We have worked with TCP and UDP client server program in the previous lecture. This client server program have many limitations, like as we have seen that server only serves one client and then exit, right? And the same limitation is of client also. And also there is one additional problem in the previous client server program, that when the client call method, which res dot we have seen receive method, then it is possible that the receive method will only return one byte. That is, as we have seen that we are passing argument 1024, right? So as we have seen, 1024 is the buffer size argument, which is the maximum amount of data to be received at once. That means it does not mean that the receive method will return exactly 1024 byte. It is a maximum amount of byte, right? And also send also behave this way. Okay, the same way. Send method. Send returns the number of bytes sent, which may be less than the size of data passed in. So it means that we are responsible for checking this and calling send as many as time as needed to send all the data. So if we summarize then we have two problem at this point. The first one is how do we handle multiple client connections concurrently, and the second one is that we need to call send and receive until all the data is sent or received, right? So in this lecture we are going to deal with these problems. So what can we do to solve this problem? So to solve the problem of concurrency, there are many approaches. As we all know that the traditional choice is to use thread to deal concurrency, right? And the more recently a popular approach is to use asynchronous IO. Okay, it is basically introduced as a standard library in Python 3.4 to deal with concurrency. Let's see the traditional method first. That is, we will see the handling multiple connections using thread module in Python. I hope you all know about threading. We will going to write code of multi-threading server which can work with multiple clients. So we will write the code of one multi-threaded server and two client in this set of lectures. So let's start coding. Open your IDE. Firstly, I am going to write the server program, multi-threaded server program, and I am using PyCharm for coding. Okay. So as we all know now that first we have to import the socket module of Python. So import socket, and also here we have to import another module, that is thread library for multi-threading. So right, from underscore thread import star. So I have imported all the method. Now let's create a socket object using socket method of socket library. So server socket is equal to socket dot socket, right? Let's declare host and port on which we need to communicate with client. So let's declare some variable. So host is equal to, let's say I am going to connect 127, that is local machine, that 127.0.0.1, and port say which is in the range we already know, so let's say 1233. Yeah. And also we have to declare one more variable, that is thread count, which tracks the number of thread running. We will see what this variable is used. Let's first declare. So thread count is equal to 0. Okay. Now let's bind the host and port to the socket server we created above in the program. So if it binds successfully, then it start waiting for the client. Otherwise, it just return the error that occurred while establishing a connection. We have seen this in the previous lecture, so I hope you are all able to understand this concept very easily. So try, and we are going to write in the try and accept block, right? So try server socket dot bind host comma port, and accept, we will print error if any error occurred. So accept socket dot error as e, print that error e. And now let's start listening. So server socket dot listen, and here we have seen that we have to pass some arguments, so let's say 5. And here let's say I am printing here waiting for connections. Okay. Now here we need to support handling multiple clients or thread at the same time simultaneously. So for that we need to create a function that handles request from individual client by a thread, right? So let's define a new function named client, let's say client underscore thread, which connect to each individual client on different addresses given by the server, right? So in this function we are going to use receive function to get data from each client independently, and then we will simply return the reply to the particular client with the same message, right? With a string concatenated says hello, I am server in the beginning, right? So let's write this function. We have already seen the use of receive method and send method in the previous lecture. So so to do write this function, we have to receive, to do this reply and send, receive and send, we have to take a argument, a connection object, right? So such that it is able to send and receive the data from the client. So let's define in such a way like this. So define client underscore thread and here I have to accept an object, so connection. And now let's say I'm going to send, so connection dot send, and suppose I am going to send a welcome to the server to the client, so str dot encode, and message is welcome to the server. Now uh, now let's start a infinite loop. In that infinite loop we are going to uh, receive a data from a client in this infinite loop. So data is equal to connection dot recv method. Here I am passing 2048. This is the maximum byte which it can receive, and let's say I have to also reply to that client. So reply is equal to hello I am server, and then I am passing the same hello I am server, and data dot which I have received the data, I am again forwarding it, again sending that data. So plus data dot decode, and we have already seen this, and we have to decode into UTF-8 string format. Now if not data, then we have to break this infinite loop. So if not data, break, and we have to send this reply to the servers, to the client. So connection dot, and here we are using send all function which try to send all the reply to the client. So connection dot send all str dot encode. Here I am passing reply, and lastly we have to close the connection. So connection dot close. These things we have already seen in the previous lecture. So if you are facing any problem here, how I have done all these things, so please refer to the previous lecture and again come to this video and again start from here. So now we have to now accept the client socket connection, right? So since server runs all the time, which means that we don't want to make that our server got stopped, right? So for that we need to use again the infinite while loop to make it run server endlessly until we manually stop the server. So let's write a infinite loop while true. Here I am accepting the connection. So client comma address, as we already know that accept method gives two returns two things, that is a client object and address, and address contains IP address as well as port number. So let's also print it out. So print connected to address 0, that is IP address, and address 1 which is port number. So I have to convert into string, so str address 1. Okay, now here there is a difference. So here I have to call start new thread function, right, to generate a new thread. Here we have to pass that function which we have defined, that threaded client, and that client object which we have to pass in that function. Okay, right. So we have a client object as well as a function which we have to generate a new thread. So let's pass it, and after generating new thread we have to increment the thread count. So thread count plus is equal to 1, and here we are printing the thread count, how many thread is running. So let's print it also. So print thread number plus str thread count, right? And right, yeah. And after that we have to close this connection of the server socket. So server socket dot close, right? So now we have completed the multi-threaded server socket So, program. So, in the previous lecture, we had seen the code of multi-threaded server which accept or handle multiple clients simultaneously. Now, in this video, we are going to see client program and we will also see the interaction between multi-threaded server and the two clients. So when multiple clients can connect to the server and each time a client connect to a corresponding thread which is created for handling client requests. So let's write the source code for the client side so that the client can connect to the multi-threaded server. So open up your IDE and I am using PyCharm here for coding. Firstly, as we all know that we have to import socket module of Python. So let's import socket. Now let's create client socket object. So client socket is equal to socket dot socket, right? Now what we need is to assign same host and port number to the client as we defined in the server, right? If otherwise it will not able to make the connection between server and the client as we have already seen in the previous lectures. So let's copy from there. So let's copy from the server. So host is, as we know, host is 127.0.0.1 and port is, let's say, 1233, which is in the valid range. Now we want to set up a connection, right? So we use connect method of Python socket library. We have already seen that connect method establishes a connection with the server using host and the port number, right? So let's and we know that this always be in a try and catch block, try and accept block, sorry. So try client socket dot connect and here we have to pass the tuple. So host comma port, okay. And if it is not able to connect, then it will print an error. So accept socket dot error as e print str of e. And also, yeah, here I am writing print waiting for connection. Okay, yeah. So now what we want is to make sure that client keeps running as the server is running, right? So for that we need to use a infinite while loop. So let's say while true, and also let's provide input option to the client so that it can send data back to the server, and along with this we also use receive function to receive the data from the server side, right? So let's put all these things into this infinite loop. So let's input is equal to input, let's say something, right? I am taking an input from the user and let's send this. So client socket dot send and here we have to encode str dot encode, here I have to pass input, right? And also let's take a response from the server. So response is equal to client socket dot receive, here I am passing maximum byte is 1024 and also I am printing the response here. So print response dot decode UTF-8, right? And also let's remember that from the server side we are passing welcome to the server. So let's also print outside of the infinite loop, so that we are also able to print that message also. So let's print it here. So response is equal to client socket dot receive 1024 maximum byte, right? And here let's say print response dot decode UTF-8. Yeah. So yeah, now the code is completed. So let's run the code. So firstly, we have to run the server. And as you see here, that let's run the code, right? And let's run the code. And firstly, we have to run the server code. So let's run it. So after running server code, let's see, as you see here, that it says print waiting for connection. Now let's run the client code. Yeah, client code runs successfully. As you see here, the output we are getting is waiting for new connection. Okay. And yeah, welcome to the server. And it is saying say something. Again, let's see the server output again. So as you see here, it is saying that connected to this specified IP address and port. And here you see that it prints thread count is equal to 1. So yeah, first client is successfully connected to the server. Now let's again come back to the client output, and here I am giving input as hello server. So yeah, so we get the output as hello I am server, hello server. So yeah, it is working fine, and we are successfully interacting with the multi-threaded server. So let's see it support multi-client or not. So again I am making one more client. I am not going to write the whole code again, just copying the code of the client and this client and paste it in another file. So let's run, so let's do this. uh, okay, yeah, so let's run this second client. So yeah, so let's see the output of the server again. So as you see here, the thread count becomes 2, right? So connection, it means that connection gets established with the second client also. Here you see connected to, and this IP address and port number. So yeah, so our multi-threaded server is able to interact with the multiple clients. So we have successfully designed the multi-threaded server as well as multi-clients, 2 clients. So I hope you all enjoyed the lecture series of Python socket programming, and you are all able to understand this lecture. So thank you very much guys. Thank you.